Alright, so let's quickly solve this example. So we are given x to be R2. Alright, so that shows for each point in x, it has two components. So we are asked to, this is our metric. So we are asked to describe the open ball centered at 0. So 0, we have two components. So this is z in, which is what? Z1, Z2 in what? In R2, such that, so we have 0 and what? And Z will be what? Be less than 1. 1 is our radius here, right? Okay. So remember the definition for 0z. So this is 0z, right? So this will be sum, right? Sum of z squared all raised to the power what? 1/2. So that is what we have. So this is equal to z in R2. We know what that is. So if you rewrite this, if you substitute 0 and z, right, you have summation I equals 1 to 2 z squared, right? Z squared, zi, right, squared raised to the power 1/2 is less than 1. So now you can square both sides. When you square both sides, watch carefully. Square root goes here. 1 square still remains. What's it called? Still remains 1. So you have z in R2. So sum of these, right? Sum of these simply means what? Sum of these simply means z1 squared plus z2 squared. Z1 squared plus z2 squared, which is what? Which is less than 1. So this is what we have, right? Z1 squared plus Z2 squared, which is less than 1. Remember, if you remember the equation of a circle centered at 0, right? The equation of a circle, right? So remember our center here is 0, right? 0, 0. So AB is 0. So we have x squared plus y squared equals our r radius is 1, which is 1, right? So this is a unit circle, right? A unit circle. So we have a unit circle. I can actually do this. Why did I do that? We have a unit circle, right? So but now we are having less than 1. So it is not actually equal to 1. Remember, these are two different components, right? So this is not equal to 1, but it is less than 1. So it is less than 1. So it will be inside the circle. So this boundary is not included. So this is just what? It's just the interior of a unit circle. Interior of a unit circle. So when we have less or equal to 1, we can have a disk, right? We can have a disk. When it is equal to 1, then we have a unit circle. Then if it is less than 1, then we have what? We have the interior of a unit circle. So that is the description for this open ball defined, describing that on this metric. All right, so let us solve one more problem in this aspect and we move to, I think, open set. See you in the next video. Thank you.